Hello friend, my name is Derek Harder, and in this video we're going to continue our discussion about file I/O, about processing files. We'll get a little bit more complex. We're going to be sticking with sequential access of text files, but we're going to look at what are known as records. So organizing files into records which have fields, and then processing them record by record. Okay, and actually in this video we're going to tackle two separate topics. So we're going to also look at Python exceptions, which is the last part of the chapter from the textbook that we're using for this course. So we'll explain what an exception is and how to use them in application programs. Okay, so if you're ready, let's go ahead and get started. So a record is just a set of data that describes one item. So a record is a fundamental, it's a basic computer science concept. So, it's been kind of reinvented. It goes by many names. And these all maybe are slightly different, but they all kind of have a lot of overlap. So, if you ever heard of a user-defined data type, a compound data type, a row in a database, like a structure, an object, or a class. These are user-defined types. These are all kind of referring to the same idea. In computer science, it's really just a collection of related individual items that all are information about one particular thing. Okay. So data that's stored in files is frequently organized in records. So a row in a database is a record. We're going to be looking at using sequential files, but to organize data as records. A record is a complete set of data about a single item. Within a record, then there's individual fields. So a field is just an individual piece of data within a record. So to be a little bit more concrete and visually, we think of a record as something like this. So if we have, if we're trying to create some application of employee information, a record might contain three fields: the name of the employee, their ID number, and the department that they're in. Okay, so that's basically what we mean by a field. And what's being hinted at here is, since we're going to be still using a text file and line-oriented processing, basically, each record in our files are going to be stored as three lines. So a record will have three lines where the first line is the name, the second line is the ID, and the third line is the department. Right? So if we look at our file, if we have three records, we would actually have 9 lines in the file if we're using a sequential ASCII text file. Name, ID, department for the first employee, name, ID, department for the second employee, name, ID, department for the third employee. So a typical application working with records, whether it's a database application or a simple file-based application or a web-based application, these are just some examples of the basic functionality that all these kinds of applications would have. You need to have the ability to add new records or delete existing records. You need to have the ability to bring up an existing record and maybe modify it. So, a person changes department or something like that. Their salary changes, you need to modify their record. The ability to search for a specific record to bring up the information about something. And the ability to display records. So often this might be a separate subsystem where you have different kinds of displays, often called reports. So I need to generate a monthly sales report, or I need to generate a monthly burn down report for my software engineering department, that kind of stuff. Okay, so I'm going to spend just a little bit of time. There's a couple of examples our textbook gives, so I'll just look at the example of a coffee database record where they give examples of all of these using a file to read and write the records to and from. So let's start with an example of adding records. We can't do anything until we actually first have some records to do any of the other kinds of things like modifying and deleting. So in this case, if you look at this example from our textbook, there's really only 2 fields in this. So we use a file for our permanent storage called coffee.txt. Notice this is the first time I didn't show any examples of appending. So since we're adding, if we open it up in A mode, we're only doing writes here. So this will actually just end up writing past any existing one. So if this file doesn't exist, it'll create it. If it does exist, it leaves everything that's already there still in the file. And then these individual writes will add new lines. And notice, again, we're doing line-oriented processing. There's only 2 fields in this record, so it's a very simple record. So our coffee database just has a description of the coffee and how much we have and quantity of it. Okay? So if we run this one, oops, change directory here. So if we run this one, so we have maybe a Jamaican blue roast, maybe 5 pounds of that. And I'll add 2 in here. So notice there's already a copy.txt. When I just hit return on this one, it should have done a write. So I should see that, so this might not show up until we close here. So let's check this out. So let's add a second one. So I'll just do Maxwell House. Let's say we got 8 pounds of that. So, so yeah, we still don't have anything yet. So we'll just exit out of there. So yeah, at this point, we were doing the write. So you notice that it's important. So things might not get flushed out to files until you do the close here. So you don't want to forget those closes whenever you're opening and processing a file. So notice, what we're using to define records here are very simple. However many fields we have, there'll be that many lines per record. And the fields have to always be in the same order. So I can run this again to add, let's say, a third one. So say we got 6 pounds of this one. All right. So now we have a third record in here. Okay. So let's look at the example of doing a report, or basically showing the records. That's show coffee record. Show coffee record. So all this does is open up the file for reading, and we do line-oriented processing, right? So here, since we have 2 lines per record, it can often be easier to use this format instead of the for loop, because we start by just entering the first one, but then we're going to use this and read in the quantity and then read in the next description here, but then this will read in will be an empty line once we hit the end of the file, right? And if we're not at the end of the file, this will kind of pre-read the next line, then we go to the loop. I'm sorry, yeah, this will pre-read. This is where we're reading in the next line, and this reads in the quantity here. We're making use of the R strip, and so on. And all this is doing is reading in all of the records. So we have to have 2 things. We have to get the quantity and the description for each record, and we just display those. So the result of running the show is we should just get all 3 of the records successfully read out here. So here's an example of how a search might work. So there's different ways you could do this, but basically we're going to figure out, we're going to ask up front what coffee we want to search for. And then we're just going to, again, we're using a sequential file. So here is an example where we might want to use like a random access file. But yeah, in any case, since we don't have any organization, we don't have any indexes on these files or anything, we do have to do a sequential search. So we're going to have to check every one of these. So if we're searching by description, all this does is all these loops are going to be pretty similar. It's going to read each one in there, try and checking if we find the description that we're looking for. If we find it, we show it. If we go through the whole loop and we never find it, we keep track of that with we're using a Boolean variable as a flag here, which will get flipped to true if we ever find it. And if at the end, if it's not found, an appropriate message is displayed. So if we want to search for a record, let's say like that, so it's going to be pretty brittle, but if we exactly match the description, it'll pull that up and show that entry from the database. And if we don't find it, it should detect that and say it wasn't in the database. So modifying a record is going to be particularly, it's going to be the most difficult example that we have here in this one, because if we're working with the file sequentially like this, we're going to have to read it in. And while we're doing the read in, we're basically performing the same search we did before in order to, in this case, we only had one other field, so we have to search by the description and modify the quantity if we find it. Right? And if we modify, though, we need to write, while we're reading in, we're writing everything out. So we open up two files in this case, open up the file that we're searching and modifying, and open up a temporary file. And while we're reading in, we're writing everything to the temporary file. Either the modified one when we find it to be modified, or if we didn't make any modification, we just write it the original record without any modification. And then at the end, we haven't talked about these, but we did talk about modules. So there's a module called OS for doing, you can use that among other things to do file operations. So here we can have it remove a file and then basically rename the file so that now our file with the potential modification for the quantity that we asked to be modified is coffee.txt like it was before. Okay. So if we run that one, I'm just going to show an example of a successful modification. Again, if I wanted to modify the Kona Peaberry to have a quantity of 4. So here the quantity should be an integer. So it's only expecting whole integer values. So here's an example of an exception. We'll talk about that in a second. But let me try that again. So I want to do the Kona berry in a quantity of 4 pounds. 1 pound. So I probably mistyped the name. Peaberry again. So there, after we modify it to 4, it was 6 originally. So now it should be 4. And then finally, deleting, again, using sequential access is similarly complex to what we just did for modify. We have to do the same kind of thing of opening and then writing stuff out to a temp file. The difference being, instead of writing out a modified record, we just don't write out anything if we find the item that was to be deleted, so that the resulting temporary file has everything that was there before except for the item that was to be removed. So if we run that and remove the one that I've been working with, and then we show them, so we should now be back down to just 2 records since I removed the Kona Peaberry from there. So anyway, that was a quick example of, basically this is a very fundamental, typical type of an application, which is the purpose of this course is about applications programming. So lots of applications fall into this general category where you're maintaining a database of records of some kind. And the fundamental operations are going to be the things like we just showed. You need to be able to add and remove records, modify ones, and maybe generate reports and things on the existing items that you have in your database. Okay, so now we're going to move on to a different topic. We're going to talk about exceptions in Python. So many high-level programming languages have mechanisms for allowing for errors to occur and then to be able to detect and possibly handle them gracefully. So an exception in a programming language like Python is an error that occurs while the program is running, causing the program to abruptly halt. In some languages that allow this, you can try and catch an exception. So in Python, you use a try except statement to detect and catch an exception, and if you anticipate an exception occurring, you can put these in, and then you could do something else instead of just having the program halt to handle that error. Okay, so what happens for an exception is you'll get a traceback, which can sometimes be a bit hard to understand, mysterious, but it's an attempt, if the error isn't handled, it's an attempt to indicate what happened, the type of exception, and the code that caused it to be raised. So some exceptions, I don't know about many, but a lot of exceptions can be prevented by careful coding. So for example, users are often going to mistype or give you bad input. So you have to do input validation whenever you're getting input from users before you use that data to do calculations with. But some exceptions are a lot less likely to occur, a lot less, not easily able to be anticipated. So you can't always anticipate beforehand what kind of exceptions are going to happen here and there. So in Python, the try except statement are what's known as an exception handler. We'll see an example of that here in just a second. So this is code that responds when an exception is raised. So instead of just halting the program, we go to the except block statements and execute those. And potentially recover from the exception or do something about it. So if the syntax for the try except exception handler looks like this. So it's try with the colon, so that means that we have a block of statements, and if any exception occurs in here, these except statements will happen. Now it's optional to give an exception name. So if you give an exception name, only if that exact type of exception is raised will it be handled. And you can actually have multiple excepts here to handle different kinds of exceptions if you need to. And you can have a default one. So a lot of the stuff we may or may not talk about in this video here, but it is discussed in our chapter. So like if you give an except with no name here, that's kind of like a default exception handler. So any exception, if not explicitly named and handled, would be handled in your last default exception handler. So let's just give a few examples of some of those things that we just discussed. You have already seen some examples of exceptions in these videos. So, an easy one to understand is if you try and, so we're actually entering integers here. If you try and divide a number by 0, that's kind of an undefined result. So actually an exception is thrown by the Python-based language here, the code that implements division. And so here's an example of that traceback message that we're talking about. So it's giving you an indication. You get a stack. So main was entered, and we got down to this line on main. So main was called. We got down to this line on main. So I guess the stacks go from kind of like top to bottom in the function calls here. And this is trying to point to what caused the exception here. So we mentioned careful coding. So this is an easy one. To kind of anticipate that you don't want allow people to enter 0 here because that's not defined. So if we do that instead of an exception, you can prevent an exception being thrown. by just checking that we're not doing an illegal division there. So another example of things that can cause exceptions, converting things from ints to floats, you need specific formats for the strings for these conversions to work. And I think we've even shown these happening before. So, if you're not doing input validation on these, like if I work 1,000 hours and I separate my stuff by commas, that's not allowed as a string literal that can be recognized and converted into an integer by the int function here, right? So it'll throw a value error, unable to convert, or like it showed in the textbook, if they don't specify, if they try to enter in spell it out instead of a number, that won't work. So anytime you are going to use like an int or a float on input just directly entered by a user, there is a possibility that they aren't going to give type in a correct string that can be converted in the right format by these built-ins, right? So if you're doing input validation on those, you would always have to have some sort of a try method. So since a value error is what is thrown if you don't give the right input here, we're not completely doing input validation, because we would have to put this in a loop and go back and have them try and enter it again. And we might want to do these individually to do full input validation, but this is our first example of a try except block. Right, so we can handle that value error exception. In this case, the only thing we're doing to handle it is we're just printing out, instead of printing out the stack trace, a slightly better error message. But we are doing something with that exception if we generate it. So if we run this one and I enter in 40, as soon as that exception occurs, it'll jump down here and print this, right? So notice that all these will happen, all these lines will be executed. So if I enter in something valid, it'll keep going. But if I enter in something valid here, so I have $10 an hour, and just type it or something, it'll generate the value error and it'll go into the exception handler here. Okay, so as I mentioned previously, you can handle multiple exceptions in a try except block. So often code in a try block can throw more than one type of exception. And the best practice is you really need to write except clauses for each type of exception. You need to be specific. And I already mentioned you can have an except clause that doesn't list a specific exception. This will handle any exception that's raised, but that's usually considered bad programming style. So usually if you are not anticipating beforehand what the exceptions are, you shouldn't just try and handle any generic thing. You should let some stuff go ahead and halt and cause a stack trace to happen. So So just as a quick example of handling multiple exceptions, if we put the whole open processing and closing a file inside of a try except block, we can handle an IO error, which is typically going to happen because the file is not there, or something happens when we're trying to read in the file, performing these the read lines that are happening in the for loop here, or value errors can occur if we have lines that can't be converted to floats. And then here's an example of what we're talking about of just a catch-all exception at the end, that if anything else happens, it would catch it there. And finally, I'll just mention two other things. I won't show the examples for these, but you can actually add an else clause to a try except. So you have try, except, and then maybe an else if you want to. So the purpose of this is it's a block of statements that's executed after the try block, but only if no exceptions were raised. So, you can have stuff that handles for the exceptions, but sometimes if no exception, so sometimes you're expecting one or another exception, and if no exception happens, you need to know that and maybe set a flag or do something else if you don't get one of your exceptions that you're expecting in a block. Also, there's something called a finally clause. So you can have try, except, else, and finally. So again, they should all be aligned, like the try and the except and the else and the finally. So this executes whether an exception occurred or not. So unlike the finally clause, which only executes if an exception didn't occur, this will always execute. So after all the try statements, and if an exception occurs after the exception handler statements are done, if there's a finally block, those statements will always be executed, both with or without an exception. Okay, so that's it for this video. So in this video, we first talked about processing records, and we gave a simple example. So you can define and use records in a sequential processed text file. So the basic way to do that is that we define a record as having multiple fields, and then each record will, like if we have 3 fields in a record, we would use 3 lines for each record in our text file. And then the next record would be the next 3 lines, and so on. So that would be the classic basic way that you would do record-oriented processing if you're doing sequential text or text formatted file. Okay, so I encourage you to read the Wikipedia definition about user-defined types or records. This is a basic computer science concept. There's lots of names that have a lot of overlap, but they all kind of refer to the same idea. It's a collection of fields, and then the classic application of that is like a database application where you need to maintain a database of records and be able to add, modify, delete, and create reports and things on your database application. So, and then we also talked a little bit about exceptions. You probably will have to use an exception in some of your assignments. These are a formal way of handling errors in Python code, Python language, and many high-level languages have similar exception processing mechanism. So in Python, you use these try except statements to handle an exception and maybe do something about it when they're raised. So that's it for this video. I hope these things are useful for you. Let me know if you have questions or comments about the videos, and I will see you guys in class then.